Section 5.4, Day 2, completing the square. Essential question, how do I solve quadratic equations by completing the square? Please write that down. There are 5 different methods that can be used to solve quadratic equations. So far, we have used a graphing calculator, factoring, square roots, completing the square, and the 5th method, quadratic formula, will be used in the second half of the chapter. All of these methods find roots, zeros, and x-intercepts. And all of the methods obviously find the same roots, zeros, and x-intercepts. There are some times when factoring is not possible. Square roots may not be possible, so then we might use completing the square. Quadratic formula is the method that always works, and there are no exceptions to that, and we will talk about that when we get to that lesson. Here are the steps again to completing the square, and we will go through these steps as we go through the problems. Example 1. First thing we are going to do is we're going to collect the variable terms on one side of the equation and the constants on the other. That means I have to subtract 12 on both sides. Next, if there is an a other than 1, we would have to divide both sides by a to make the coefficient of the x squared term 1. Next, we're going to complete the square by adding b over 2 squared to both sides of the equation. Well, b is negative 8, so b over 2 squared is going to be negative 8 over 2 squared. That would be 16. Next, we're going to factor the variable expression as a perfect square. By factoring, we're going to create a binomial squared. That will be an always. So every time we factor this, it's going to create 2 binomials that are identical. Next, we're going to take the square root of both sides of the equation. When we take the square root of a squared, this cancels, the x minus 4 comes out, and we get a plus or minus on the other side. That always happens when we take the square root of a square. Now we're going to add 4 to both sides. X is equal to 4 plus or minus 2. But we're not going to write the answer like that because we can write 4 plus 2, that's 6, and we can write 4 minus 2, that's 2. So these are our zeros, our x-intercepts, our roots. We can also write them as points if we choose to do that instead. Example 2, we will save for class. And now we're going to go on to example 3. So recall that the vertex form of a quadratic function from lesson 1 looks like this, where the vertex is at HK. We are going to complete the square to rewrite a quadratic function that is in standard form. We're going to put it in vertex form. Recall, we talked about this, that even though quadratic functions are written in different forms, they still are the same parabola. They're just written differently. All right, here we go. We have to set the function equal to 0. Let's go back a minute to example 1. We didn't have to set it equal to 0 because it already was set equal to 0 for us. That still is the case here because by setting f of x, which is equal to y, equal to 0, that's telling me that we're going to find x values that have a y value of 0. That's telling us that we're finding x-intercepts, which are also called zeros, which are also called roots. Next step, we are going to get the constants on one side and the variables on the other. Oops. Okay, let's try this again. We look and the term in front of the x squared is a 1. We don't have to divide anything. Now what we're going to add to both sides is b over 2 squared. Well, that's going to be 16 over 2 squared, which is 8 squared, which is 64. That's 76. And we're going to factor that into x plus 8, x plus 8, a binomial squared. Now, at this point, we would normally take the square root of both sides and finish and find the zeros, the x-intercepts, the roots. We're not doing that right now. We're trying to put this in vertex form. So our next step then is to move the 76 back over. And now we can call that f of x. And the vertex is h. Okay, so let's highlight what we found just now. This is called vertex form, whereas up here, this is called standard form. It's the same quadratic equation, the same parabola, just written differently. Standard form versus vertex form. Example 4. Write the function in vertex form and tell us what the vertex is. This is standard form. It's nice to know the difference between the two. Okay. Number 1, oops, set the function equal to 0. We need to put the constants on one side and the variables on the other. And I notice that there is a number in front of the x squared, which means I have to divide everything by 3. I cannot continue, until the number in front of the x squared is a 1. We haven't had to do that yet. Now we have. Now I can continue and I can add b over 2 squared to both sides. Well, b now is -6. -6 over 2 is -3. You get 9. So -2 plus 9 and x squared minus 6x plus 9. Factor that into a binomial squared. We're not going to take the square root because I'm not finding the zeros or the roots or the x-intercepts. I want to put this in vertex form. And the vertex, h. Okay. Notice how quickly we can find the vertex when it's in vertex form, just HK. When it's in standard form, takes a little longer because we have to find the axis of symmetry. That's vertex form. That's standard form. They are the same parabola, just written in different forms. Example 5, we're going to do in class. Video questions. Please complete these in your notes.